Good afternoon, class. My name is Bubakar Dabo, and I will be your instructor for the course Hematology for the semester of fall 2019. Briefly, our today's topic is the coagulation cascade. First of all, it's very important to understand the terminologies that we will be going through. But we will at the we'll go through certain concepts. Just example hemostasis, and then we will also discuss about the intrinsic pathway, the extrinsic pathway, and also the common pathway. And then we will later discuss about the diagnostic importance of certain coagulation disorders and tests, and also the interpretations of results, and basically we'll have an overview of a summary of the whole cascade. Um, to start with, coagulation, as you know, means the conversion of soluble protein, which is fibrinogen, into insoluble uh, protein known as fibrin. So that's the goal of coagulation, something that is soluble to convert it at the end into insoluble fibrin mess, or it's called fibrin plot. So that's the goal of coagulation. So basically, we look into hemostasis. Hemostasis, hemo means blood, and stasis implies or means stoppage, which is to stop bleeding. So hemostasis basically is a mechanism, or is a sequential order that happens in order for our body to adjust when the endothelial vessels are broken or are injured. So that's the definition of that. But looking at the intrinsic pathway, we have precursors, which is the prekallikrein high molecular weight kininogens, will activate, with the uh, platelets, which are negatively charged, the phospholipids, negatively charged, will activate this intrinsic pathway, and factor 12 will be converted into 12A, and then 12A will convert into 11, and 11A with calcium will be calcified and convert into factor 9. Factor 9 combined with factor 8, this is what we call the prothrombinase complex. So the prothrombinase complex will go ahead to convert, to activate factor 10, which is the intersection between common pathway and the extrinsic pathway. So factor 10 with factor 5, that will also activate thrombin, prothrombin, to be activated into thrombin. And it is this thrombin that cleaved, it cleaved the fibrin polymer into monomers, fibrinogens, and then later fibrinogen is polymerized by factor 13 into insoluble fibrin clot. Basically, that is the intrinsic pathway. So the extrinsic pathway is activated with factor 3 and tissue factor. With calcium, we have that will activate into factor 10, and factor 10 again will activate will activate prothrombin into thrombin, and thrombin will cleave fibrinogen into fibrin clot, forming a fibrin clot. We will look into the sequential order, just like I have alluded to. So how this process take place in the body, and also, as you can see, the mechanism is a chain reaction. Is it's a chain reaction, and all of them are proteins which are produced in the in the liver except factor 8. And these proteins are called zymogens because they are in the plasma in the inactive forms. So they're not active until something activates them. Then they will be activated, and then they will have a sequential effects, and that will trickle down to cause a formation of a clot. Uh, so basically, we have a fibrinogen group, which is comprises of factor 1, factor 5, and factor 8 and factor 13. These are consumed in coagulation. So in conditions like DIC, in DIC, disseminated intravascular coagulation, which is a consumptive coagulopathy, these factors, which are factor 1, factor 5, factor 8, and factor 13, are all consumed. And we also have what is called as the prothrombin group, that is factor 2, factor 7, factor 9, and factor 10, and vitamin K dependent factors, which are factor 10, 9, factor 7, and factor 2. We also have the contact group. These are the precursors to the intrinsic pathway. So, if to look at the medical diagnostic significance of these factors, the intrinsic pathway, which is is measured using the APTT, which is activated partial thromboplastin time. This is the time that is used basically to see when somebody bleed, how long it is going to take before the clot formation take place. If in fact all the coagulation proteins are not deficient. For example, in the intrinsic pathway, one of the tests, coagulation tests that we do, is the PTT test. And then if we have factors such as factor 8 that is deficient, which is hemophilia A, so, and then we have, that could be due to factor 8 deficiency if we have an elevated PTT, and also it could be due to somebody being on heparin, because heparin, what it does, it inhibit thrombin, so it's an anticoagulant, so it will kind of block, extend the time, elevate the timing of the PTT time will be elevated. Or if we have factor 9 deficiency, which is also known as a Christmas disease, factor 9, that also you will gonna have a clinical significance of that. You will have an elevated PTT, and also factor 11, which is also in the intrinsic pathway. This is usually found in the Jewish population, the Jewish descent of the Ashkenazi Jews. Those are very common coagulopathies, diseases that are related to bleeding disorder, is found in this Jewish population. Factor, the extrinsic pathway, the most important thing to remember about the extrinsic pathway is factor 7. So when there is an elevated extrinsic pathway, which is the PT time, thromboplastin time, then that will suggest a deficient in factor 7. In fact, we use the INR, the International Normalized Ratio, also as a matrix to measure the PT. So basically, that is clinical significance of elevated PT. There will be a deficiency in factor factor 7. And also we have something that is a platelet disorder, has nothing to do with coagulation, but it's called van Willebrand disease, which is very important to mention here because when you do certain assays, certain tests, factor 8 and factor 8 and van Willebrand disease will be reduced. So that's something that later into the semester we'll discuss about. That is bleeding disorder, van Willebrand disease. But of now, we have to understand basically the concepts of coagulation. Um, Also, we have factor 13, which is not measured by either of these pathways. So factor 13 doesn't is not measured by the intrinsic pathway, it's not measured by the extrinsic pathway. At the same time, it's not measured by the common pathway. So factor 13 basically is also called the fibrin stabilizing factor, and this factor is very important because it is this factor that makes sure um, the clot is stabilized, it's not soluble. So we have the 5 molarity 5 urea 5 molarity solubility test. This is a test that is used to determine how long last the clot will be formed. um, Usually it takes more than 24 hours to for clot formation. So if you are deficient in there's an assay that tests your clot, the clot will retract easily. So that means you if you injured, you will not heal properly. Those are like a factor 13 deficiency. But one thing that I want to allude on is um, is this. Okay, this is very important to remember that factor 10 can be activated by reaction in either pathways. That is, factor 10 is the injunction wherein either factor the intrinsic pathway can can activate it, and at the same time the extrinsic pathway also can activate factor can be activated by factor 10. So that's very important to remember. And then also you have to know in situation like examination like the ASCP, the board exam, the questions are there that will say which of these factors is the intrinsic pathway factors or extrinsic pathway. So you should be able to know that which is which. Um, that is very important. So basically, this is how the coagulation cascade is a mechanism that it work in a way by only the activation of proteolytic enzymes and cofactors, proteins, cofactors, and also some other chemicals like we call them the the serine protease. The serine protease are the active forms of these proteins or enzymes that cause these kind of reactions to get to the formation of insoluble fibrin to insoluble insoluble fibrinogen to insoluble fibrin. So basically, this is a short lecture, and then hopefully, as we progress, we will get to understand more. And questions are welcome. The floor is open. Um, we can discuss at length, any issues that is not clear to you, and we can interact, engage one another, and then hopefully, you will understand, the layout of the lecture material. But if you are unclear on any issue, You're welcome to ask questions. Thank you all.